Hello, I'm Robert, a fact checker and science blogger, and helping people scared of many things. In this case, it's about people who are scared of asteroids. And so, first thing is to realize that asteroids are really, really rare that they hit Earth. I mean, after all, think about it. Do you know of anyone who's been killed by an asteroid? Most people would not be able to name a single person that has been killed by an asteroid. And yet it does happen, but it is very rare. It's a few times per century. And so the last really big asteroid, and people get very scared about these huge asteroids because there's been a lot of publicity about it. So I'm just trying to guess before I get to it. When do you think, how long ago was the last asteroid that was big enough to have some very minor effects on the global weather, equivalent to, say, one of the largest volcanic eruptions, a bit short of a supervolcano, but just a very large eruption that would cool down the climate just a little bit for a few weeks? How long ago do you think that asteroid was? I'll come to that in a minute. Anyway, so the most likely next asteroid we can expect is a harmless splosh in the ocean. And so I'm going to explain why that is. And I'm not saying we shouldn't look out for asteroids. I'll get onto this, but this has been blown out way out of perspective. That people are thinking that it's almost certain they're going to have a huge impact by enormous asteroid due to constantly repeating extremely fake news in Google News. And NASA have never given a single asteroid warning. All of those are fake news stories. And they have totally unrealistic fears. And yet if you stop and think about it, your grandparents, great-grandparents, great-great-grandparents, indeed, have you ever seen in a history book any stories of even going back thousands of years about a big asteroid impact? So how can it be a very high chance of an asteroid impact this century when it's never happened in all of recorded history? That doesn't make sense. We have got much better detecting them, and so we are actually much safer. We are the safest, as I will explain, of all the generations of humans. The current generation is the safest there's ever been when it comes to asteroid impacts. So the most likely one, and there have probably been quite a few of these that nobody even noticed, is an impact in the ocean. Through human history there have probably been many of these, and we would just have no way of knowing they ever happened. And the reason for that, and so just to putting that in perspective, so this is, if you look for what's the most likely news story for an actual impact, there's actually quite a large one. We've got already our news for fireballs predicted in advance, but something that was actually big enough to actually do something and actually warn people, then this is by far the most likely, would be something like that. Now, this gives you this rough scale. That's the scale of a plane, of a jet, passenger jet. You can see huge splosh of water. You wouldn't want to be anywhere close to that at the time, but you could be flying past, not very far away. If this was in the middle of the ocean, it would be absolutely harmless, because tsunamis, they spread so far because they're not just high, but they're very, very wide. Indeed, over the ocean, a tsunami could only be a few tens of centimeters high, but spread over 100 kilometers. And then that size of wave spreads very efficiently across. If it's 100 kilometers wide, then even if the ocean was a couple of kilometers deep, then even if the ocean was 5 kilometers deep, it would still spread very efficiently. If it's more than 20 times, if the wavelength is more than 20 times the depth of the ocean, then it spreads without losing hardly any energy. And so that's why tsunamis are so devastating. And when they come to land, even though they're very long wavelength, but they'll start bunching up, and then you get this big tsunami. But this kind of a splosh like that, if you've got a small thing of tens of meters in diameter, just that size, it'll create a wave about similar in scale. It won't spread very far at all across the ocean. It just flops out and it's gone. And and especially since it creates a hole in the ocean which sucks the whatever you get a splash out, then it gets pulled back immediately afterwards, which counteracts a lot of the splash out. And so if you look at the simulations, there's really, it almost cancels itself out. It goes in and you get a splash out, but much of it you get pulled back in again, and not so much spreads out into the ocean. And so this is the most likely impact we have in the sea. A small splosh like that, maybe 10, 20, 30, 40, 50 kilometers in diameter, and that would be totally harmless. And you, as long as you manage to warn anyone who's happening to sailing. Obviously, if you're sailing just across that spot at that moment, it's very bad news. But the sea is very big, and if you warn people in advance, you can totally prevent it. So this is the this is a video that sort of shows what it's like. I don't know if there's any sound with this. I'll try and switch it off if there is. This basically, that's basically what you would get. You see, and you see how the ripples just very quickly fade away, and there's almost nothing left. You get something like that in the ocean, and see, you think to notice how very quickly the ripples fade away, and then it just flattens out. Very different from a tsunami. So that's what would happen if you had a big splosh in the ocean. So anyway, these are all totally fake asteroids. Killer warning, could hit Earth. None of these were ever. And NASA, they sometimes, when they get a particularly bad one, they'll say there is no asteroid threatening Earth. They do their best, but they can't counteract every single asteroid warning which you get in most weeks, or certainly most months during the year. We'll get a new totally fake asteroid warning on Google News, because Google News doesn't filter out the exaggerations of the sensationalist press, where they say these things are just made up. They say NASA killer asteroid warning. NASA didn't issue a warning. It's just a lie, complete lie, just made up, and that goes to the top of Google News. And Google News doesn't filter that out. It doesn't check if the title of a Google News story at the top of the page, when someone searches for NASA asteroid warning, they don't check if the journalist lied. Google News don't check that, and they just do that to get clicks and views. NASA asteroid warning, all of those are fake. Usually the Daily Express, they make a completely fake, made up lie about NASA warning about an asteroid about to hit Earth many times a year. So it's no wonder that people get scared of it. And these are the same people, if you know what kind of place it is, they made up this story about Freddie Starr, a comedian, eating a hamster. No hamster was harmed in the process of making that story. It's a made up event, never happened. That's the kind of people who make these fake NASA asteroid warnings. And so you've got to be aware of that. And now, I asked you when was the last one. This was the last one, 700,000 years ago, before Homo erectus. This is the hominid that saw the last big asteroid of 1 kilometer in diameter. 700,000 years, that's 7,000 centuries ago. And there's no reason to expect this century to be any different from the last 7,000 before that. And that's before Neanderthals, before Homo erectus saw it, before Neanderthals, before Homo sapiens. No Homo sapiens has ever seen a big asteroid, even as big as 1 kilometer, where it's just big enough to have some cooling of the atmosphere through the dust clouds that get spread out, and then they spread out in the stratosphere. It gets a little bit cooler, a little bit darker in the others all around the world for a few weeks. And no Homo sapiens has ever seen such an event. You'd have to get into unless they got a time machine somehow. We don't have time machines. These are the tektites from that event. These are the actual mixed up with the tektites, which are these bits of molten rock that were thrown up. And this is where the debris all spread. The main debris spread. That was the region. The strewn field, as they call it, where all the bits and pieces fell to the ground after the impact. So quite a large area. But if you go to modern times, the Chelyabinsk meteorite that was the 15th of March. That was mainly from the glass blown out. It was the sonic boom. So the fireball goes whizzing through the atmosphere at great speed. It breaks up very high up, far too high up to harm anyone. And although it's equivalent to a nuclear bomb in the amount of energy, there's no radioactivity. And the only risk to humans from the actual fireball itself is of sunburn. If you're out of doors, you can get a bad sunburn if you're very close to the fireball when it's suddenly the sky goes very bright just above your face. And that's the risk. That's the main risk from it. Some people got bad sunburn, and then flying glass because of there's a big boom. You've got a very big boom. It blows out windows, and then a lot of people were badly injured. So you can see, just giving a bit of warning to stay away from windows and to shield your face from sunburn. They wouldn't even need to have done anything else but that. Sadly, most asteroids of this size, well, perhaps half of them would be seen this size, but half of them managed to come in from the sun side of Earth, where for small asteroids especially, we don't see so clearly. And but they nearly saw it. If Chelyabinsk had been twice the size, they'd have seen it a few months earlier, but it was too small and it went past unseen. The only one recorded in history of any size before that, actually recorded in history books, is Tunguska in 1908. And that was really quite a big one. And that's probably not once a century thing, that's probably a bit rarer than that. But this is a very remote part, and so now I want to go down to the statistics. And so if you look at the area of the Earth, then you can see that most of it is sea. Then you have some land, and mostly desert and so on. If you go and divide it all up, then this is how it goes. So I think I've got to get rid of that. I want to bring that maximum. Just a second. So you've got most of it is ocean. Then you've got ice sheets. You've got grassland. You've got forests. You've got crops. You've got deserts. Then that is the urban area. So in the next 10,000 years, we can expect maybe 100 impacts of the Chelyabinsk skies and larger. And of those, you can expect a bit larger than Chelyabinsk. I think it's a little bit larger than Chelyabinsk. And if you can, of those, you can expect one will be in a city region. And you can expect 71 to be in the oceans. And that's why I said the most likely next impact is going to be a splosh in the oceans. You know, out of the next 100 impacts, you can expect 71 of them to be in the oceans. And then you can expect 7 to be in grassland, you can expect 6 to be in ice sheets or tundra and so on. This is just because they land randomly, there's no pattern to where they land on the Earth. So it's just by the area and they come from all directions by the time to get to Earth. And it's just pretty much the area. This is a very rough calculation. I couldn't find someone who had done the detailed modelling of it all. So it's just a first approximation to give you an idea. And that is something like this. Certainly most of it is ocean. And there's some slight asymmetry, I think, as to the different latitudes and things. I haven't taken that into account, but it's not going to make a big difference. And that's another breakdown. But anyway, rest like for the Pacific in 40, which of the oceans? So you've got 30 in the Pacific, 20 in the Atlantic, 14 in the Indian Ocean, 4 in the Southern Ocean, 3 in the Arctic Ocean, and so on. It's another way of breaking it down. And so we can expect. So the most important thing is that you are very safe from these asteroid impacts, and because they're very rare. So I go back down to here, and first of all, yes, I want to explain how rare these asteroids are. So let's go down and down and down, and let's get let's get the bit about, right, so I said you do occasionally get deaths from asteroids. This is one story which seems reasonably credible. In Mexico, May 1946, 8 people were killed and 28 injured. That's in the entire world in the last century. That's probably the biggest. And then there was the 3 reindeers herders were killed in Tunguska in 1908, and there are a few other of varying credibility. There's where you cannot always be entirely sure if that's what it was. There have been a few people who have died of asteroids. When people say nobody's ever been died, it's pretty clear that some people do die every century. However, compare that with death from hailstone, and in the United States, the last death from hailstone, which is a very rare death, not many people die of hailstone, was in the year 2000. This was a pizza worker, and he saw his car being damaged by hail. And so he went out to his car, he managed to get out to it safely, and he drove his car out of the hail. Then he got killed on the way back. And if you stop and be a bit thoughtful about it, then it's not very wise to go out of doors and try and drive your car to safety if it looks like it's being dented by hailstones, because you're going to be harmed by them too. And that's basically what happened to him. And so you've got to be very careful. If you see hailstones that are big enough to damage things, they can kill you if they are that big, which is very rare. This death by hailstone doesn't normally happen in the United States, very rare nowadays. It used to happen much more often earlier on, when there were lots of people working out of doors, and they were in remote places and they couldn't get to cover easily and quickly, and they'd be working all weathers and not retiring because it's a little bit bad weather, and people used to die of hailstones in the United States more in the past, but it's a very rare death nowadays. And then, but if you go and look at the death by asteroid, there's never been a death in the United States by asteroid. There's a hoax from what turned out later to be a hoax in the 19th century, and in the 20th century there's one lady, and a bit of a meteorite came through the roof of her house, and she was very badly bruised on her thigh, to the extent she had to be treated in hospital, and that is the only known casualty of a meteorite in the United States to date. So it's a very, very rare thing to happen to you. So, and then we are, people say, oh, but we're going to be hit by a big one sometime. So we have these huge telescopes. This is another one that's going to be built in the near future, the Vera Rubin Observatory. And this is going to be built, I think it's first light sometime in 2022 or something like that. And this is going to be able to see 4 times deeper, about 64 times the search volume of all the telescopes we've got so far. It's going to be exceptionally sensitive to seeing asteroids. So that's going to make a huge difference to asteroid discovery. But when you get these news stories about all these asteroids that are flying past, do bear in mind that the reason that these have always been flying past, there have always been asteroids flying past, but our ancestors going back centuries and centuries didn't have a clue they were even there. And before, I think it was 19th, 18th, 19th century, whenever it was, they didn't even know asteroids existed. So we are much safer than them. They had no way of knowing until they were hit. But we can know. And where we are, this is the graph I was looking for. So this is the atlas, which is designed in order to spot these asteroids in advance. So the 2 telescopes in Hawaii, and they're set up to look at the sky in such a way as to preferentially notice asteroids that are on an impact trajectory to Earth. And they expect to see nearly almost all at 1 kilometre. Now, we already know nearly all at 1 kilometre anyway. So, and this is just those 2 telescopes. There are other ones looking as well, which will make that even more easier to spot. It's very difficult for a 1 kilometre asteroid to get past our telescopes without being seen nowadays. And indeed, if there are any left, they're almost certainly orbiting just the other side of the Sun from us, in an orbit that is almost exactly the same orbit as Earth's. and just slightly less than a year or slightly more than a year, and so they've been behind the sun for 10 years or so, and maybe a bit longer now. And so an asteroid like that, when eventually it peaks around the sun, it's not likely to come anywhere near us very quickly. So you're most likely, with a 1 kilometer asteroid, you're going to have multi-years of warning over such a period of time, then we would be able to prepare and deflect. And so those 1 kilometer ones there, pretty much eliminated. I mean, as the asteroid experts say, don't tell people that we can totally guarantee to see them, but I mean, just so close. It'll only be a few more, another decade or so, and we can just be really totally certain. But we only know of one. We've got either 95% of them or something, maybe even more, 98%. I'm not sure what the latest figure is, but amongst all the asteroids we've found so far, which is over 900, well over 900, then there's only one that has a very remote chance of an impact in 2880, 4 centuries from now. All the others have been removed from the risk list. There are none left in the risk list except that one, 1950 DA, which has this very remote chance expected to miss in 2880. So out of the few that are left to find, just a few dozen, it's not very many at all, it's extremely unlikely that any of them have even a remote chance of an impact in the next several centuries. And the largest one is, and that we haven't discovered, is likely to be just a few kilometers. It's not going to be larger than 10 kilometers. The largest not yet discovered. We know all the ones of 10 kilometers and larger, and that's the range of the dinosaur asteroids. So we know all those ones, and they are there are 4 asteroids and there are 4 comets, and none of them can hit for more than in the next several thousand years. There's one in the year 4000 I won't talk about. I could talk about that separately, but so far in the future, and again, it's expected to miss. It's 1 in a million chance, so 1 million to 1 that is going to miss, and we've got thousands of years to prepare for it in that very remote chance of eventually refining its orbit and discovering we have to deflect it. So we don't need to worry about the ones of 10 kilometers and larger. We don't need to worry about comets, because although you hear these comets quite often, they typically pass by about the distance of the sun or so, which is so far away that you'd be going around the world constantly for 20 years, non-stop in 747 to go, 19 years to go to the same distance to the sun. It's very, very far away when these comets fly by. The closest any has come is Lexell's comet, which after a flyby of Jupiter, and we'd likely have spotted it doing all that, and then it came, 6 times the distance to the moon, something like that, 6, 7 times, I forget now, but many times the distance to the moon was the closest it got, and that's a vast distance away. The moon is a very far away, and so we don't need to worry about the long period comets. There are times, and have been put it in your diary for your great grandchildren. Say, tell them to keep a bit of an eye out for comets 1.3 million years in the future. Then we need to have a little note on our calendar: look out for comets, because we have a star called Gliese 710 that is going to be flying fairly close to our solar system, well beyond the planets, but close enough so it might deflect some comets. So if you put a post-it note, you have been some very durable format to your great grandchildren on your kitchen table or your kitchen wall, and then to look out for comets in 1.3 million years from now. They're very uncommon at present. If you look at the proportions of them compared with the short period comets, most of which we're kind of following and knowing, and then the longer period ones, so although they are very spectacular, they pass by at a huge distance, and the Earth is a tiny target compared to the distance they typically fly past. So we do actually know how to deflect them, we could do it with, if there really was the incentive to do it, then we can build an infrared laser, high energy infrared laser, which you couldn't run it for long. You only run it for a few minutes a day before it heats up too much. But that pulse every day, just for a few minutes, and a 100 gigawatt, I think, array in a desert, a large array, lots and lots of infrared lasers. And they're actually thinking about doing this for breakthrough starshot, to send a small spacecraft to nearby stars. And so if they do build that, it'll dual purpose as a method of deflecting comets. And that can deflect even a pretty large comet some years in advance, a year or two in advance, which we can hope to spot it that far in advance. And so we certainly have the ability to do it if we thought it was important, but it's not the focus because it's so rare. But it might come as a side effect of sending small thin film spacecraft to the nearby stars, which we can do with breakthrough starshot, which could get there maybe 30-40 years to the nearby star by sending them at a quarter the speed of light or something like that. What was the distance for that anyway? Oh, tenth of the speed of light, I think. Anyway, yes, not a quarter, tenth. Anyway, so this is about how we can predict fireballs. We don't really need to go into this just now, but this is just basically showing how we are managed to detect these things already. These very, very small fireballs, we're already detecting a few of them. We can't expect to detect the majority at all, but it does show that the systems are working right down even to that size. And then there's the European Fly Eye telescope array, which is going to be one of the others amongst there are going to be lots of telescopes around the world that are around to help with early warning. But if any of you watching this, or any of you happen to know a friendly billionaire who has an interest in humanitarian benevolence for humanity, and who has a few tens of millions of dollars or $100 million pocket change, then one thing they could do to greatly reduce the risk of, there's a very strange funding hole in NASA. So NASA can find the United States, they've got programs to fund the detection of asteroids using the ground-based telescopes, and they've got quite a lot of funding for that. But they don't have funding for space-based telescopes to look for asteroids. So the people who are trying to get space-based telescopes built, they have to go through NASA. The problem is that NASA is not permitted to accept a project on the basis of its ability to protect Earth and to protect humans. They don't have that remit. They can't do that. So, very strange funding gap that I'm not sure what that's all about. I can talk about it in a minute. But very strange funding gap that this is one, but there's actually better. Which one is this? Yes, here we are. This is NeoCam. This is actually one of the ones that they've tried to get passed. They've tried over and again to try and get that to be passed by NASA, and it would certainly be very effective at helping to protect Earth from detecting more of these asteroids early on. But the problem is that NASA, by its remit, has to evaluate this project by its scientific merits and not by its ability to protect humans. That's just written into the way NASA works. So time after time, these projects lose out to other ones that are more scientifically interesting. They have to try and make them as interesting as they can to NASA. They would find an interesting thing about asteroids, but NASA says, but it'd be much more interesting to send a submarine to Titan's ocean, or I can't remember. I don't think they've actually done that yet. But I can't remember which one this was competing with. I think it might have been the one where they sent a mission to look very close at Psyche, which is a very large iron asteroid, and that's very much more scientifically interesting than looking at lots and lots of asteroids, which we already know lots about already. And so this just loses out, and even though it's not very expensive, and it's one of the lower price missions that NASA do, and there are several others that they're doing, and they can easily fund it, but they can't. They're just not permitted to do that. and it's sort of unfair for the scientists that they lose out to this mission. It should be ring-fenced. Now, I know that Hillary Clinton, that was one of the things interesting about her, is that she thinks this is important. So she would have probably found some way of finding some funding for space. I'm not quite sure what her details were. I'm not sure that she got far as actual proposals, but she thinks asteroid defense is very important. And I don't know what Joe Biden's view is on that, but I haven't heard him talk about it. But I think this is the sort of thing. But if maybe the politicians will eventually come to this, and they will plug this gap. And if not, so the two ways of doing the two things so if you can have no friendly millionaire, a friendly billionaire, not a millionaire won't have enough, then or lots of friendly millionaires. So there's two ways of doing it. First of all, there's the searching, filling up the gaps of all the small ones, and you can do this aperture sensitive, this aperture synthetic aperture tracking. And so what I'm saying is we have very effective methods of detecting these asteroids already, but it's going to take another decade or two to fill up all the gaps to have the best possible predictions for the smaller, especially for the smaller asteroids, and filling up the gaps below the 1 kilometer. And if you want to, especially like that hamlet that I told you about, and a few people dying, that may still happen this century, that it could still happen, that this very occasional, very rare death by asteroid could still happen, although we would spot perhaps half of them in advance, but the other half we might miss. It isn't impossible that we have a news story where someone has been killed by a small asteroid, because we are not yet at that level of assurance where we would be able to spot all the asteroids that could, for instance, have killed that small hamlet, may be responsible for killing 8 people in Mexico that I talked about. So it's not a personal risk. Your personal risk is just about zero. But with 7.8 billion in the entire world and far more connected, it's not impossible we do have a future news story where a small number of people die as a result of an asteroid impact. And this is the sort of thing that could stop that. And it would also indirectly also stop the larger ones too. But it would find the 100-meter ones, but they're very rare, and it would find those too. And but most of all, it would be stopping the small ones. And so, if you want to, again, you have this philanthropic billionaire who's got $100 million of spare change, then you could finance something like this, or you could finance. There's another system. There's a constellation of 8 satellites that would be a very efficient way of spotting them, which would orbit just outside Venus's orbit and looking outwards towards Earth's orbit. And this could find very quickly way down to quite small numbers, small sizes. And then this other one, the solar system from, this is an early warning system. And there hasn't been so much interest because the thing is that Congress set a target of trying to find nearly all the asteroids down to a particular size. They didn't set a target of trying to have an early warning system for asteroids, but we could have one because the main gap is for the sun side of Earth. On this side of Earth, on the night side of Earth, then the likes of Atlas and all our other telescopes, the ESA FlyEye, the various other, or European FlyEye, I can't remember who organises it. Lots of small telescopes are gradually filling out, the LSST, the Vera Rubin telescope and others. They are gradually filling up the daytime side on the ground. So, and that is nearly all the way around, almost to the sun, because we can see all the way to there with just after, whichever way around, just after sunrise, just before sunset, then we can see very close to the sun. But then as it gets lighter, then it's harder to see the smaller asteroids, and when it gets much lighter, you can't even see the big ones. So that's why we've got this gap towards the sun, that basically that region. And so this would give us 12 to 24 hours advance warning of anything approaching in that gap, which is our gap that we can't fill up from the ground. And so this is another project, and I don't know, they don't actually cost it, but you're talking, I mean, $100 billion is a kind of level where you could expect to pay for one of these projects. And that sort of level, it's not $1 billion, it's more like $100 million or less. And so if you put these two spacecraft up there, not very big ones, they don't need to be huge telescopes. They have the advantage that they're in space, and you're talking about a few tens of centimeters diameter telescope, and so to give the size, I'm not sure I've got it written down there, but and so for instance this one, it's a rather ingenious design. It's got a mirror that just kind of spins around, and it lets it kind of, so it's not got a stationary mirror, it's got a spinning mirror, and it's constantly, every few minutes it's looking through this kind of guardrail of this line here, and if anything crosses it, then it detects it, and then if it does, then it gets the other one, which is over here, and doing a similar thing, and then spot it from a different angle and give an idea of the direction that it's travelling, and then they can work out a trajectory, and then of course they would start pointing other instruments at it, and then they would be able to work out where it's going to go. Okay, this is it just being, so here we are, first detection with this one, you see, and then this one then swivels around and she starts focusing on that, and it detects it there, and it can just very quickly just swivel its mirror around. It's not moving the satellite. This is the that's the swiveling mirror there, slewing mirror, and so that is a very fast way to detect asteroids, and you make this just narrow enough so that each asteroid at a typical speed would be seen several times as it crosses that beam, and then very sensitive kind of narrow beam but wide enough, and so you detect asteroids from the sun side with 12 to 24 hours, which is plenty of time. I mean, you could have it on the news, you could have your alerts on your mobile phone, and most people in the area would know that this asteroid is headed for that particular spot, and so the people living in that hamlet, then they'd wake up, or they'd get someone wake them up and say, did you know it's about to hit your hamlet? You know, maybe even get the police out or something and go around to them and wake them all up if it's at night. It would be quite feasible to do those sort of things if you had this kind of alert system. And for some reason, this has had much less attention than the big telescopes on the land, combined with this kind of gap in the budget, that they haven't ring-fenced anything for space telescopes to look for asteroids. And I think that should, I think that definitely deserves a place to be debated in Congress and hopefully pass some kind of small bill. Someone should put forward a bill towards Congress to fund this, a ring-fenced bill to fund just a one-off bill, $100 million, do the proper financing beforehand, take it to Congress and say, we need to have this. And then I think they might well be able to get the majority on that. It certainly could be worth a try again. If any of you are House of Representatives or Senators or someone in a position to start a bill through Congress, and that could be something to consider, either this one or the other one, filling up the gaps. And anyway, so that's that. I'll stop now. This is rather longer than I expected again, but just to say, what if the Egyptians had developed asteroid detection telescopes and they would still be waiting for the first city killer impact? So that will help put it in perspective. It makes a lot of sense to have the telescopes looking for these things, but don't overstress about its effect to you, because your personal risk is absolutely minute, and you're far more at risk of hailstones. Most people don't worry about dying from a hailstone, and you're far more at risk from lightning. Again, it's not a top preoccupation for most people. And the things like traffic accidents and medical conditions and accidents around the home and these things are the things that you really need to think about. And keeping healthy, keeping fit, be careful of which way you go right now to protect yourself against COVID. These are really significant things that you do need to think about. You don't need to worry about these asteroids. The Google News is full of totally fake, made-up stories where the journalists basically just tell a lie in order to get clicks and views. And I don't think they should do that. I personally think that we need some kind of... I think because so many people actually... This has severe effect on people's mental health. And I help people who have, like for instance, had to give up college because they got so scared of asteroids because of these fake stories. And people again feel suicidal because it's so scary for them and they don't know how to handle the fear. And this, in my view, there should be some code of conduct for journalists, even sensationalist journalists, I think, should not run stories about the world ending. I think we should just stop all these stories saying that the world is going to be destroyed by an asteroid. Fake stories, totally fake stories, just made up. I think there should be some kind of code of conduct for journalists, that you just a voluntary code of conduct, hopefully, amongst journalists, not to run stories that make readers suicidal or that severely impact on their health, that are totally made up and fake. My own personal view is that this is not acceptable. It's not ethically acceptable for a journalist to run a story that they know is completely untrue and that they know has severe impact on people's mental health and that can cause some of their readers to be suicidal. I just don't think that's even remotely acceptable, and I think we need raised awareness of that this is not acceptable. This is not what journalists should be doing. They can have sensationalist stories about finding alien babies or whatever it is that they like. They can make anything else, but please not these stories, these kind of stories. Anyway, my personal view. I'll now upload this and hopefully help some of you who got scared by these fake stories. Totally fake, totally made up. No truth to any of them. I have debunked so many fake asteroid stories over the last 5 years that I've been doing this. None of them had any basis in truth.